Hey everyone, today we'll be looking at the telephone challenge from the Ethernaut set of challenges. We have a really quite a small smart contract here, and the idea of this level is to become the owner of this smart contract. So if we have a quick look at this, let's see what we can do here. So it's a telephone and it has a constructor which sets the owner equal to the message.sender, so whoever constructs the contract will become the owner. And so there's a function here called change owner, and it takes in an owner address, and it says if the transaction origin doesn't equal the message.sender, then we can rewrite the owner. So really what this challenge is all about is this transaction.origin and this message.sender and what they really mean. So the transaction.origin is where the transaction is originating from, as in the address of the originating transaction. And the message.sender is the address of whoever sent the message. So you may think, well, that's probably the same thing, but no, that is not the case. The reason that this is, there's a difference between these two is that you can have smart contracts call other smart contracts. And so when you call another smart contract, the message.sender is not going to be the address of the originating person who called the smart contract. It's going to be the address of the contract that called said contract. I know I said contract a lot of times there, but that's okay. And so transaction.origin is a way to find out who actually originated this transaction. So if you had a wallet call a contract, call a contract, call a contract, call a contract, transaction.origin in all of those contracts context is still going to be the address of the original sender of the message. So how do we do this? Well, it's pretty simple actually. All we need to do is deploy a smart contract that will then call this contract, and we just call the change owner function to our own address. So let's go ahead and get into it. I'm going to copy this contract and create a new contract called telephone.sol. I'm going to paste this in. And let's go ahead and compile this. And it's pretty straightforward, no problem. And let's create a new file called telephone.ts. And let's get the contract address, which is located here, and paste this in. Cool. All right. So the contract name is telephone. And so before we continue, let's go ahead and create the contract that's going to interact with this contract. So we're going to contract called telephone attack. And it's going to have a telephone typed variable, which is in reference to the other contract. This is very similar to the previous challenge that we did. I'd say this one's actually a bit easier. In our constructor, we are going to set telephone equal to an address that we have set. So telephone of Chal. So we have that reference. And then we can just create a function called win, which is public. And all we need to really do is call telephone.changeOwner. And we're going to change the owner. We're going to pass that in as a function. So we're just going to have the owner as a variable there, and we can save that. Cool. All right, so we can go ahead and compile this, make sure this is all good. This is a very simple smart contract that should win it for us. So we come back to telephone. We have this all ready to go. So let's go ahead and deploy the other smart contract as well. And so we do this through attack contract equals ethers.get contract factory. And this is going to be telephone attack. And it's going to be deployed by the signer. So then finally, we need to await this. I always forget the await. Let's format this. And then we want to instantiate one of those contracts, which was like this. And we run the deploy method. Now the deploy method requires a constructor parameter, which is the address of the challenge. So again, we have that up there. So we can just use the contract address. So now we have our malicious contract. We can just quickly log this and say malicious contract deployed at, and we can pass in the attack contract dot address. Great. Okay, so now after this, all we should really need to do is await the attack contract dot, I think we called it win, and this takes in a parameter, which is the owner, and this owner is going to be the player address. And again, so what's going to happen is I'm going to call this attack contract and with win. And so this is going to call this win function, and then this smart contract is then going to call this telephone function, telephone contract of change owner. And so in this case, the transaction origin is going to be the address of the player, and then the message.sender is going to be the address of the telephone attack contract, which is which has just been deployed. So after we win, we then should be able to see console.log ran the win function, checking that we are now owner. And we can then get the owner equal to the regular contract dot owner. And again, we need to wait for that. As usual, I forget. And we can say if owner is equal to the player address, then we can console.log owner has successfully been changed to the owner. Otherwise, we can just go console.log failed to change owner. Current, we can do that. We can just make this a warning, and we can show what the owner is. Owner currently is owner. Just like that. Okay, so again, just to run through our script again and what's happening. So we find the contract that's deployed called telephone. We then create a factory called attack contract of telephone attack. We then instantiate a new contract and we deploy that with a parameter of contract address, which is for the one that we are going to attack. We then log it. We then run the win function. And then because the win function will call this function in the original contract, this if statement will pass and we will become the owner. So let's go ahead and run this. So npx hardhat run, and we're going to change it from coin flip to telephone. And hopefully it all works. Let's see what happens. Bingo. Okay, so we can see that the malicious contract was deployed at this address. We ran the win function, and now we check that we are the owner, and we can see that we went into this block and say the owner has successfully been changed to this address here. So we can go ahead and submit this instance, and I believe it probably should be about 5, maybe. Now I'm going to go 2 is my guess this time. Nope. What is it? 3. Damn, so close. Okay, try again. Submit the instance. Let's see if it works. 3. Bang, all done. So you can read here, this is around the victim's address, and the message.sender is the contract's address and all that kind of stuff. So yeah, that's how you do that one. Nice and quick one for you all. And I'll see you in the next one.